Measuring intelligence without making birds act human. Welcome to Birdlens, presented by the Birdlens app. I'm Sheila.
I'm Victor. This is Season 1, Episode 5. Season 1, Episode 4 examined dense neurons and birds' big mental lives.
Before we start, you need two ideas. Birds solve survival problems, and tests can be unfair. You need no laboratory experience.
Exactly, Sheila. Bring curiosity, not a ranking chart. We will ask what a task actually measures. The fair test lets a bird demonstrate a relevant skill.
First, we trace why researchers change their questions. Then, we build fair tests around a bird's life. Finally, we inspect successes, limits, and controls.
That sequence matters. One dramatic puzzle result can mislead us. It can confuse novelty with intelligence.
Here is today's quiz, Victor. What should persuade a scientist that a bird's result reflects its own thinking? A familiar natural problem, a harder-looking puzzle, or a researcher's first impression? Hold your choice until the end.
My opinion is firm. Pause before choosing. Compare what each option can genuinely establish. I explicitly defer the answer, Sheila, until your final choice.
A key term is cognition. It means how an animal takes in information, remembers it, and uses it. Ecological validity means a test resembles challenges from the animal's real life.
Anthropocentric means human-centered. A biocentric approach starts with a species' ecology and evolution. Evolution means change across generations. Sheila, is bird intelligence one ability?
Victor, is bird intelligence one ability, or can different skills develop separately under different pressures?
Different skills can develop separately. Tool handling, remembering stores, and navigating a flock may not travel together. One score can hide that pattern. A bird can be strong in one domain and ordinary in another.
So, a bird may fail because our question mismatches its senses, body, or daily problem. Is that a fair starting point, Victor?
Yes, Sheila. A failed task may reveal a bad match, not a deficient bird. We must inspect demands before judging performance.
Compared with the prior episode, today we increase technical complexity. Historically, animal tests often borrowed human-style tasks. Researchers wanted comparable scores.
That motivation risked treating birds as incomplete people. The field evolved toward adaptive specialization. It asks what selection favored in each species' environment.
Selection means useful inherited traits become more common through reproduction. A specialization is a skill shaped for recurring demands. How does that change experiments?
Let's start with the bird's sensory world and behavior, then add controlled choices. Finally, compare tasks. A test battery is a set of tasks checking whether skills connect. Physical and social tasks can reveal different patterns.
My understanding is that fairness means copying the wild exactly. If a jay ever sees a tube outdoors, should we avoid chin-up tasks altogether? Please correct me, Victor.
Improve that, Sheila. Ecological validity does not require a wilderness replica. It requires meaningful links to the bird's capacities or natural problems.
Like testing a swimmer in water instead of asking them to climb a ladder, relevance matches ability to setting. Is that relationship right?
Yes, the swimmer's movement maps to the bird's relevant perception and action. A novel apparatus can work if it does not secretly block ability. And now, as we glide from theory to implementation, let's hear from our next host, who will break down how these principles apply in the field.
I assume a successful crow understands water causally, but an edge case is simple practice with heavy objects. How can we separate learning from understanding?
Use comparison conditions where simple preferences fail. Crows preferred water, sinking objects, solid objects, and high water levels, yet harder tube width and U-shaped tasks defeated them.
For a real study, I would randomize positions, hide the researcher's knowledge, and test several objects. Would that reduce accidental clues to birds?
Yes, blinded procedures prevent informed people from signaling answers. Random positions reduce side habits. Odor controls prevent food smells from directing choices.
Compared with one viral crow puzzle, a battery is stronger. A pitfall is calling failure stupidity, avoided by checking vision, motivation, movement, and familiarity.
Precisely. Clever Hans seemed to calculate, yet he followed subtle human cues. Good experiments test competing explanations and then merely removing obvious errors.
My practical tip is simple. Ask, what else could explain this choice? Then look for a control, a comparison that rules out another explanation.
Excellent. Controls turn an impressive observation into stronger evidence. What research fact stood out to you, Sheila? One wild magpie study found tentative separation between physical and social tasks.
Scrub jays remembered what food they cached, where they cached it, and when it was cached. That meets behavioral criteria for episodic-like memory.
Right. Episodic-like memory means linked details of a past event. It does not claim human-like inner experience. Their recovery matched a food storage problem.
I once watched a jay vanish behind shrubs, then return directly to one spot. My mnemonic is what, where, when. Test the life lived.
Nicely put. Your observation is not proof alone, but it suggests a testable question. Science turns such moments into structured comparisons and controls. That protects us from storytelling after a striking sighting.
We moved from a fairness question to test design. Victor, what should listeners carry into the quiz answer? Carry that standard into the answer.
Intelligence is not a human resemblance contest. It is evidence about information use under conditions fitting birds and excluding shortcuts.
My quiz answer is a familiar, natural problem, tested with strong controls. That combination best shows the bird's thinking, rather than expectation or arbitrary obstacles.
Exactly. Natural relevance alone is insufficient. Controls alone cannot rescue a mismatched task. Together, they make interpretation far more trustworthy. Different brains can reach complex solutions.
To recap, cognition is information use. Ecological validity connects tasks to life. Batteries reveal skills. Controls block cues. Mixed results show boundaries, not shame.
Next is Season 1, Episode 6, From Insult to Compliment. We will connect these lessons to changing respect for bird intelligence. It will ask how an old insult became a prompt for respect.
Subscribe to and rate Birdlens. Share this episode with a curious bird watcher. Download the Birdlens app for this show and many more podcasts.